Right, I'm going to spend a little bit more time discussing this than I might normally because I really want you to understand what we're doing and why. So we're going to start off with, I'll read the problem in a second, but I'm going to put a couple little things up here for you guys to copy. This won't take long for us to put together, but like I said, I really want you guys to understand what we're doing and why. And then I'm going to let you go ahead and give it a try on your own. We'll see how that goes. Okay, problem 14. The management of Madera Manufacturing Company is considering the introduction of a new product. The fixed cost to begin the production of the product is $30,000. So we'll stop right there. That means that you're paying $30,000 to begin construction no matter what. The variable cost is uniformly distributed between $16 and $24 per unit. Okay, what does that mean? That's rows 6 through 8 is where we entered that in. Variable cost of 16 to 24 uniformly distributed. Anybody want to give a shot at explaining what that is? Not that you need to know. What do you think it might mean?
That it's distributed pro rata, and that like per item it's that much.
Okay, I think you're getting it, but use different words.
Okay.
Or anybody else. So you have your variable cost. You got 16, and you got 24, and in here you got 20. So you've got 16 and 24. And well, actually it would be over on I got this on the wrong axis. 16, 24, and here's 20. And the number, the way that all the variable cost is going to be distributed is just kind of going to be uniformly through here. That means there's going to be just as many 16s as there's going to be 24s, and there's going to be just as many 20s as there's going to be 22s. Everything is uniform through that window. Okay, so uniformly distributed. Does that kind of make sense? Okay, so just as many 16s as 24s is an easy way to think of it. Okay, so the product will sell for $50 per unit. So the selling price up there, we have the fixed price. Demand for the product, because we have the cost, now we need to know what the demand is described by a normal probability distribution with a mean of 1,200 units and a standard deviation of 300. Okay, now that sounds a little scary, but don't worry about it. So we have our normal distribution. Now what does that look like on a graph? Yeah, you got the big old bell curve. So those of you that had stats just had a nasty flashback. So you got the bell curve here. So that means that, what's my range there? Normal distribution, the mean is 1,200. So 1,200. And this would probably be two standard deviations would be here. So this would be 600. And this would be 1,800. You don't need to know this. The computer will do this for you, so you don't need to worry about it. But that means that all the values, most of the values will be around 1,200. And the further you get away from 1,200, the fewer the values. So that's the normal distribution. Not 100% sure you even need to know all that to get the problems right, but just conceptually it might help because not all of them are going to be spelled out as easy as this first one. Okay, so now we need to do simulation. Now let's finish the problem. Okay, develop a spreadsheet simulation similar to figure 12.6. Use 500 simulation trials to answer the following question. What is the mean profit? What is the probability that the project will result in a loss? what is your recommendation concerning the introduction of the project? Now, all I'm really concerned about in terms of the probability that it will result in a loss, I'm not really that's not really that important to me. We'll go ahead and calculate it, but it's not that. But the main thing is we get the simulation trials correct. So I'll enter in. Oh, come on. The first part here, and we'll. Okay, so this is what it's going to look like, and we'll enter in the equations in just a sec. We only have 4 columns this time. All right, so still here typing. I'll wait another second for you guys. Now, to get Excel to do simulation is kind of cool because most of the time you have to buy software for it, but you can do it in Excel. Okay, so for trial, we're going to just number them. So trial, that'll be trial 1, that'll be trial 2, that'll be trial 3, and so forth. But what we're going to basically do is drag this. Sometimes the numbers don't drag right. We can always do that one separate. But we're going to only enter in the equations once, and then we're going to drag it down 500 rows. Just so you know what this is going to look like. So variable cost per unit. Variable cost is uniform distribution. So here's how it's going to work. Equal sign $B $7. So we're referencing the smallest value plus rand, R-A-N-D, whoops, open close, times open $B, $8, minus $B, $7, close. So what we're essentially doing here is setting up Excel to find a uniformly distributed number between 16 and 24, including 16 or 20. It could be exactly 16 or 24. And when you use the rand function, that's just telling the computer to assign a random number. So that number could be anything. So it's going to be B7, which is 16, plus a random number, times B8, which is the largest value, minus B7, which is just going to be the number 8. Okay. So I know that seems a little odd, but that's how you do a random number. What is that noise? It sounds like a remote control car.
Yeah, it sounds like an RC car.
All right. That's nice. Okay. Makes me want to play with it instead of doing simulation. You hear that sound, it's like, oh. All right. So this is basically how you do uniform distribution. And we enter it in, and it is a number between 24 and 16. So we're just going to drag a few of these down just for fun. And all of them will be between 16 and 24. You see how that works? You don't have to drag them down unless you want.
So our numbers will be different.
Your numbers will be different.
Oh.
And here's something interesting. Every time I enter a number in another cell and hit return, my numbers will change. See that?
Why are our numbers different?
Because if you're assigning, Excel is assigning a random number, and it's not going to, and it's going to assign a new random number every time. So your answers in this section will actually change all the time, and it's a little weird. It's also a little bit cool for those of us who are nerdy and like this stuff. Okay. So next, move on to demand. Now, demand is the normal distribution. So this is going to be a little bit more complicated. normal distribution because we have to deal, well, actually it's not more complicated, it just feels that way. Okay, so normal, we're going to go equal sign. Norm inverse, which is NORM INV. NORM INV. Open, rand, open close, comma, $B, $12, comma, $B, $13, close. Okay, we got it? And that's going to give us a number around, typically within 2 standard deviations, so within 600 of 1200. So if we drag these down, you're going to have most everything be between 600 and 1800, which is what we have. Now there are exceptions. You can have something under 600, and you can have something over 1800, like we have this one right here over 1800. That can happen. But you just want everything, you can tell if you did it right or wrong if everything is around 1200. Okay. And, yes?
Mine just said, like, number sign number, exclamation point. And it looks like I have it right.
There's 2 different formulas for norm inverse. There's one with a period between the norm
Yeah,
and
mine's not with the period.
It's not?
Triple check, make sure everything's right. If it's not, I'll come take a look at it in a minute. Oops. Is your column wide enough?
I tried making it wide, but
Okay.
yeah, just keeps going.
Are you using remote desktop?
Yeah.
And you are too, and it worked? Okay, well, we'll take a look at it in a minute.
Alright, thank you.
And profit. So to figure out profit, you guys could do this. I'm going to help you along, but to figure out the profit, you have to use all the numbers. So you're going to go equal sign, open, $C, $3, which is, when we go to C3, that's your selling price per unit. So and then you're going to subtract from the selling price per unit the cost per unit, which will be this number, B20. And then you're going to multiply. So that's how much so right now you have your selling price per unit minus your cost per unit. So that's your profit per unit is what you have right there. You're going to multiply your profit per unit by C20, which is the demand.
The dollar sign or just regular?
Just regular. Because we're going to drag it and it's going to change as we go. Minus $C, $4, which is your fixed cost. So it's our profit per unit times the units sold minus fixed cost is your total profit. Now you guys probably didn't need my help for that one, but it's easier because we're kind of in the follow the leader mode, but that one's actually not too complicated. All right, we all got that? We didn't get that?
I did too.
Oh, no, just made it positive.
Some of us got negative numbers.
Yeah.
You're not always going to make money. Right?
Yeah.
So negative's fine. I'll have negative ones too. Okay, so let's drag these down. I'm going to drag them down a few. Yeah, it worked. I'm going to have to widen this up a little. See, I have 3 negative numbers and a huge positive number. So this is where, just to look at these first couple, this is where you can see the value of simulation. That little variations have a tremendous impact on your bottom line. So it didn't seem like the variables were that extreme, but there can be a lot of difference. So now let's drag this down 500 rows. So let's go to 520. Actually, see the little number right there on the side? It tells me how many I've done. See, there's a little 500 right there. So I go to row 519. And I let go. And it's gone all 500 for me.
Printing this would take a while.
So now go to 520, go to 519.
519, yeah.
What if it tells you to do like 30,000?
You just keep on dragging.
Keep it on.
It's not really that much more work for you.
Yeah.
All right. So what we're going to do now, yeah, every time you hit enter it changes, which is very odd. Never get used to that. We're going to do summary statistics because this answers the questions in the book. So we're going to do our first thing we're going to do is our mean profit, which is just going to be the average of all of the estimated profits. Now, all of these numbers are going to they're going to keep changing on you. Don't freak out. And my final answer will be different, but similar to yours. So don't worry about that. So average is going to be D20, which is where we started, colon D519. Now, you can go highlight those, but I think it's easier to type them in because highlighting 500 rows is awkward. So my average right now is about 5,900.
Can you open that up here?
Sure. Okay, and when I enter it again, now I'm at 5,200. See, it keeps changing.
Could you open that one more time, sorry?
Uh-huh.
Oh, I never started reading it.
Okay, we got it?
Almost.
Oh, you guys still typing in the other stuff?
Yeah.
Okay. No problem. Okay, I'm going to show you guys a little trick to help your speed here. Highlight the parentheses D20 to D519 and then copy it. I just hit Control C. If you have a Mac, you do however you copy stuff. And that'll help you.
Quick question.
Yeah.
Can you go up to B12 and B15? I think that one could be no problem.
B12?
Yeah, I was one up, one row up.
Okay.
That's why I was numbering. It's a number.
So you got it now?
Yeah.
All right. Sure. All right. We all have mean profit? Yes?
Yeah.
Okay.
Can you click it real quick? Sorry. Okay, thank you.
Sure. All right. Now, if you copied the parentheses D20 to D519, this will go a little quicker. So standard deviation, we go equal sign, ST, DEV, and then I paste. It's the same thing. Save you the trouble of typing that in over and over again, because that's what most of this stuff's going to be. Standard deviation, D20 to D519.
What's the hotkey for paste?
What's the
The hotkey for paste.
Control V is in Victor? For copy, it's Control C. All right, next one. Minimum profit, equal sign MIN, Control or paste.
That's cool.
Oh, I just did it over standard deviation. Oops. I'll have to redo that one. And this one is standard deviation. Okay, and for maximum, you could take a guess. It's going to be MAX, paste. these next two we have to do separate. Remember, every time you hit enter, these are going to change. I mean, type something, hit enter. You can't just hit enter over and over and have it change. But every time you type something, it's going to change, and it's fine. Number of losses. We're going to use a new one. We're going to do count if. New little tool. So we're going to go count, C-O-U-N-T-I-F. And then it's going to be open, D20, colon, D519, comma, quotation marks, less than, 0, quotation marks, close. I'll leave that up for you. Basically, it's saying if it's less than 0, you're going to count it. Count it if it's less than 0 is what we, in those rows, is what we just told it to do. So it's going to count up all your negatives. Count if is a really cool function if you're working stuff in Excel. Like you're doing a big problem and you want to, or you have a long row of information, even outside of this class, and you want to know how many have the value of 7. You can just go count if 7, and it'll tell you there's 12 sevens. So it's kind of a fun little thing if you're working in Excel. It's not something you're probably going to use in your education much, but in their professional life, the projects are massive and you're given weeks to do it, and this can save you a ton of time. So count if. Excel could probably do just about anything you imagine. You just have to ask it. And the best way to do it is like if you're doing something in Excel, like, boy, I'd love it if Excel could do this. There's some geek at Microsoft that's already thought of it. Just Google what you want to do and it'll tell you how to do it. Yeah?
Can you go to standard deviation and minimum profit and maximum profit?
I think it's cool how the numbers keep changing. That is cool.
Okay, minimum.
Is it all the same? You still
Yes.
go to the back? All right.
Yeah.
Okay, thank you.
Okay, so, oops, I just messed that up. All right, and then probability of a loss. So you're going to go E526.
Would it be equals?
Yes, it would. Thank you very much. Somehow I messed that up badly. Equals E5. Having troubles. Equals E526 divided by 500. So that's just how many losses there are divided by your total number of trials. Will give you your probability of a loss. So 27% of the time I'll have a loss. And then if I... So yeah, I'm curious what you guys end up with. I'm at about 27%.
28.
Okay.
25.
25.4.
Okay, so despite all that variation and all those numbers changing and all these numbers changing, we all have about the same probability of a loss. So the Giants are going to lose 27% of the time. Remember, going back to our original example. So even with all the variables changing and everything, when it comes right down to it, it stays pretty consistent. That's how you know you have good numbers and that the sheet is set up right. Okay, let's